All right. All right, everyone. Welcome. My name is Jeremy Grelle. I'm a member of the Spring Web team for years. And today, for this particular session, we've got a couple of guests. We've got Mattias and Tim here to talk about, basically give you a few different perspectives on kind of modern client-side MVC frameworks. We've got Mattias will be talking about Angular. Tim will be talking about Backbone. Spring is kind of always aimed, even when things were much more server-centric in the web world, to sort of work with any web framework. That's always been sort of one of our goals, is to integrate with everything. And you'll find these days, I think these frameworks, because they're very REST-centric in the way they communicate with the server, you'll find that stuff just works. What we wanted to focus on today, though, is really the client side and the differences, what you can do with these frameworks in the browser to create applications. So we're going to have Mattias talk about Angular, Tim will talk about Backbone, and then we'll do a little panel at the end, give you guys a chance to just ask some questions about the two frameworks. So with that, give it to Mattias.
Okay, testing works. All right, everybody. Good morning. My name is Mattias. I'm from Toronto, Canada, and I work remotely for the Google AngularJS team. Today I'm going to talk about AngularJS and give you a small introduction. So my website is www.yearofmoo.com. My Twitter handle is @yearofmoo. I put together large articles for AngularJS, much larger than some other tutorials online, and I go into detail just about a lot of the small code examples to big code examples and so on. So please check it out. And the link to these slides is located at that address. Just wait a few minutes until anyone's got them. Is the link not working for anybody? It's working? Okay, cool. So before I get started with AngularJS, I'm going to just talk about dealing with websites versus web applications. Now, what's the problem with that? So back in the day, before we had these powerful client-side frameworks, we kind of did everything on the server end, and we just shipped out HTML to the browser directly. And then we had these nice JavaScript hooks that did some cool stuff to them. So what's the problem with this? Well, the problem is that the HTML and JavaScript are just too bound together. You edit the HTML, it causes problems in the JavaScript. You edit the JavaScript, it causes problems in the HTML. You can't really isolate the two. Then the next problem is that you have a traditional website that loads, a basic HTTP request, and then you have these small AJAX requests that kind of hook in after the page is loaded. You know, this is nice when you get it to work, but it's a ton of work, and it's too difficult to test. And all of this is too dependent on the backend. So if you use a backend framework like Spring, or Ruby on Rails, or PHP, each of these has its own method of handling templates. And you can't just, in the middle of a project say, hey, I want to use this framework instead of this framework, because you're going to have to convert all that template code over, which is a problem. And because of this, testing is kind of second, not as important as all the other parts of an application, because you can't just start testing the application midway, because you're going to have to rewrite bits of code and so on. And then the code becomes too brittle, and it's just too much work overall. So how do MVC frameworks help this out? Now, it's a great approach to this, and they're getting better every day. What they do is they have smaller amounts of HTML and JavaScript code to give you a nice, functional client-side application. And they provide a nice level of testing and organization. And the beautiful part of it is that when you design it with a client-side framework, your backend becomes irrelevant. It could be anything. All it just does is it gives you a nice JSON API, and then your front-end code reads off that API. And AngularJS does all of this and more. So AngularJS, it's a front-side JavaScript MVC framework that's made by Google. It's really gotten popular over the past year. What it does is it takes your HTML code and extends it. It gives you more capabilities of what you had before. And instead of using some tricky namespacing system or lots of object-oriented code, you're just writing a little bit more on top of the HTML that you already have. All of your JavaScript code is organized into modules, which you can reuse very easily. And routes and views are automatically tied to your application. And they make use of the HTML5 history API as well as hash bangs. And the dependency injection system in AngularJS is amazing. It can hook into services, controllers, filters, and so on. And you can reuse bits and pieces of other services and controllers directly within the code. Once you've structured your code this way, it's very easy to test. So the major features, once again, we have our nice templating system with dynamic bindings, modular JavaScript, dependency injection, routing, and a nice feature of multi-level scoping. What this means is you can have various parts of your application have data, and other parts of it inherit that data to display on the template. And of course, the animation hooks, which is a new feature in 1.2. So let's take a look at some small code examples of AngularJS. Now, this is what it looks like for a basic AngularJS application. All that's happening here is we have my name, and the ng init sets a variable to the scope. In this case, it's setting my name to my name. And the ng app tells AngularJS that this HTML page is, in fact, an application. But all you need to include is the AngularJS file. So you guys can probably guess what happens here when the page loads, and once Angular kicks in, you'll see hello Mattias show up. But that's really boring. We need something more. So in this case, what we're doing is we're making an application, and we're attaching it to the page. And we have a binding, in this case, my name again. However, we also have a model attached to an input field. This means that when you edit the input field, the binding will appear right away. And once again, we have a controller. Well, I haven't actually introduced controllers yet. The controller is a logic closure for handling the scope and handling how the data appears on the screen. So let's take actually this code, and let's copy it over into an editor. Okay, so, and let's open up a browser to that file. And let's put this side by side. So as you can see here, as I'm typing in the field, the binding updates automatically. And this is all the code that we need. There aren't any callbacks or any triggering functions which tell the page to load. AngularJS handles all of this in the background. So let's add a little bit more to this. So let's say that instead of having just one name, we want to have a list of names. How do we do that? Well, there's a nice feature in AngularJS called a repeater, and we can repeat name within a name. So that's the template code to display the names, and now let's assign the names to a scope. So those are the default names. And let's remove the binding. And now let's make it so that whenever I press enter on a button, it adds the name in the field to the list of items in the repeater. So AngularJS has these nice custom components called directives. And you can define your own directives, but there also are a ton of directives that AngularJS provides, such as click events, repeaters, show and hiding, etc. So in this case, we're going to submit when we click on this button. Better? And then we're also going to set the my name field to empty. So this is going to remove the name once it's gone. So before I test, I need to create this scope method called submit. So you notice that if you imagine using submit in your code somewhere, that's going to clash with other submission fields. You're not going to know what it is. But in this case, the submit function is tied to this scope. So if you call submit elsewhere in the application, it's not going to find the method. And wherever you put it in the scoping system in AngularJS makes it appear in various parts of an application. So in this case, we're just going to do scope.names And that should do it. So you see that? That is the list of items getting repeated. And this is all the code that was required. You're simply adding names to a collection of names as an array. And if you look at the scope values in this controller, there's no special object-oriented instantiation. There's none of that. It's just simple JavaScript. This is how AngularJS works. So now that I've shown that, let's go back to the presentation, and let's talk about modules. So you saw my example how I had a module, and I attached the module to the page. And the way that that's done is through the ng-app directive. And with module, you can include other modules directly inside of it. So you really have one top-level module which is directed to your template. And the JavaScript code looks like so. So what's happening here is we're saying a factory, which is a reusable piece of code, and we have a filter which alters data that's passed in. And we also have a run function, which is an initializer once the application is loaded and ready. So what's happening with root scope? Root scope is the top-level scope of an application. Anything you place into root scope will appear everywhere in your application. So it's kind of like a global variable system. Typically, you don't want to put too much data in here because it'll clutter your application. It'll be hard to test. But it's just the mechanism in how scopes are placed, which I'm going to talk about next. So as you can see, can anybody guess what will happen here? Guess what values is? Values is just the array of items with the first item taken out. Just some simple JavaScript code back and forth. So the scope. Think about the scope as memory for your application. Whatever you place in the scope, it can appear inside of the template. And this is how the template and the JavaScript code communicate together. So at the start of the presentation, I mentioned how difficult it is to uncouple HTML and JavaScript code. And in this case, you have both of them isolated from each other, but you have one little bridge between them, which is the scope. In this case, we have a total amount of apples, and whenever you click on a button, it's going to increase the amount of apples, and so on. It's going to update the templates, similar to what we did before. So each time you create a controller in your code, AngularJS makes another scope. It creates a scope inside of that scope inside of that scope. And all the data that you set into a child scope is self-contained in there. And that kind of isolates code from each other, and you can have various parts of your application that have their own little world. So in this case, we have an outer controller called an app controller, and an inner controller we call the inner. And we're using inner controller twice for two separate div elements. And each one of those div elements has its own collection of data, and those two data types won't interfere with each other. But if I make another controller inside of them, all of the data from the inner controller will inherit to the new controller. So controllers and templates. Controllers manage the logic of your application, and they typically handle the scope and everything that happens within the scope. And you can reference them with engine controller, which we've just seen, or you can use routing. And the way that you use routing is you use another module in your AngularJS code called ng-route, which in this case, we are defining the routes with the route provider service. And we're setting the template and the controller. So when that URL hits, it's going to instantiate the controller, run the code inside of there, display the template. And that's all you need to do to your index.html file to make the routing appear. That ng-view element that we see there, that one is responsible for displaying the current page. So dynamic templates. So now that we know how to put views, manage controllers, and scope, we want to make some parts of our application appear dynamic. Because so far, we saw a repeater, but we saw mostly data binding. And repeater is really powerful. The data binding is also useful as well, but there are other ways to show and hide data on your page. The approach with AngularJS is not to make your own JavaScript code to show and hide parts of an HTML page, because you'll typically throw that code away after a while. So we already saw ng-repeat. This one has a list of colors, and it has a function called too-many-colors, which will which will return true or false depending on how many colors you have. In this case, 5. 5 or more colors is too much. And if you look in the code below, we see this nice div element that says ng-if, and that's a simple true or false true or false div that will basically show itself depending on the value of too many colors. Therefore, if it's true, in this case, if there are too many colors, 5 or more, it's going to appear. And then the one below is the list of colors. So ng-include works similar to ng-view. What will happen is whatever template you give it, it will load it into the page. So in this case, we have a select field, which has ng-model. Whenever you change that select field with the 2 items inside of it, the ng-include automatically updates the content. So it's going to download frame1.html or frame2.html. ng-show and ng-hide. ng-show and ng-hide set a CSS property on an element to make it visible and not make it visible. When you click on the show and hide buttons, this affects the visibility of the element. So in this case, div ng-show will be on or off. And simply setting it to true or false does that within the ng-click expression. So typically, what makes an application dynamic is having data coming in from a server. Now, with a server-side framework, that would be a database. But since we're using a client-side framework, that would be the server. And in this case, it's JSON data that's getting returned from the server and being thrown at the page, and that will automatically update. Since you're using these Angular directives in your page, whatever data you give it, whenever the data changes, the page will automatically update itself. So if you use AngularJS for a long time, you can turn your website into a real-time website by having a constant stream of data coming in. So this is the JavaScript code to perform an HTTP request. So what's one thing that you notice with the code here is that there's no callbacks at all. It's a simple HTTP method to the server, to a JSON API. And you might think that this is actually synchronous, that it's getting blocked when it's going to the HTTP server, but no, it's actually asynchronous. What happens is HTTP returns a promise object. And that promise object, once it's been fulfilled, when the data comes from the server, then it updates the content that it's referenced to. So in this case, colors is going to be a promise, but then when it's done, it's going to turn into an array of colors. Or it's going to return into a null variable, depending on if the colors API doesn't return anything. Resource is the same thing, only it provides more features. You can make a RESTful resource system in your AngularJS code. So in this case, we're making a color class, a color resource, which reads from an API, and it has methods for fetching and pulling, updating and destroying, creating information. And the code below is the same thing as before. You're just doing query instead of http.get. So, directives. Directives are those special ng-include, ng-repeat, ng-show attributes. And AngularJS provides a various way of styling those in your HTML code, so you don't have to follow one specific way of coding HTML, which is nice. However, my preference is to use attributes directly. So, in this case, we define a directive on the app variable, which is our module code, and we're setting it so that when you click on the element, it alerts something. This is probably the most basic directive example you can think of, so I'm going to show something a little bit more involved. In this case, we have a full directive declaration, which sets its own scope, and it sets a variable called times to 0. It has its own template, which gets included inside of the div tag, and it has an expression within that template. Then we have controller code, which updates the scope, and then we have our actual JavaScript code. So what's happening here is when you click, it's firing an event up to the controller, and the controller updates the scope. But one extra piece of information that you'll notice here is that we have an apply function. Now, the apply function isn't required when you're doing Angular code within Angular code, but as soon as you go outside of Angular, whether you use another plugin, tool, framework, you're going to have to tell Angular to update itself and check the page. This is what apply does. So, unit testing AngularJS provides, there's two types of testing in AngularJS, end-to-end testing and unit testing. Unit testing uses both Jasmine and Mocha, and this is an example using Jasmine. Now, it takes a little bit of work to set up a testing framework with AngularJS. Typically, you do something called Karma, which instantiates multiple browsers and tests them all at the same time. I don't have the code in this example, but I do have an article which I put together that explains how to do it. And in this example code, we're simply testing to see if the controller sets that array of colors. In this case, we want to check if green is there. So this is what end-to-end testing looks like. So AngularJS is currently switching to another testing tool called Protractor, which completely dominates the existing testing tool called Scenario Runner. But for now, since that's not fully complete yet, I'm just going to show an example of Scenario Runner. In this case, we're testing to see if the page works, and it goes to the home page. And when it goes to the home page, we want to see some welcome text within there. And if you look here, you'll notice that you can have something asynchronous instead of the expect function. So as soon as that returns a value, then it does the assertion. So this is nice for a web page that takes a long time to load, or when you're waiting for certain components for a page to load. So a new feature, and this is what I helped put together for AngularJS, is the animations driver. For the directives that come with AngularJS, they have animation hooks. So if you have a repeater, there's enter and leave, move, add class and remove class, and so on. ng-show has show and hide events, and so on. So to enable animations, you include the ng-animate module. And there are two types of animations that it supports, CSS and JavaScript animations. And when it comes to CSS animations, it could be transitions or keyframe animations. So the nice thing about these animations is you don't have to have any code inside of your HTML code. All you need to have is a special CSS class, so you can hook into that class using CSS. So for ngView, for example, whenever a new page comes in, you would have a transition to fade out the old one and to fade in the new one. That's what the code in here is. And what it does is it adds these ng-enter and ng-leave classes temporarily to hook into the animations. JavaScript code is very similar, but it's defined inside of the module. So if you're using an animation framework that's a little bit more advanced that you can't handle with CSS, such as Greensock, you would put the code directly into JavaScript. In this case, we're using jQuery to perform the same operation of fading out the old element and fading the new one. When your animation is done, you call the done function. OK, so I'm going to show a demo repository, which is something I put together for this presentation. What we have here is we have a list, and this link right here is to the GitHub repository for anybody who wants to download it. It doesn't require a backend, so if anybody wants to put a backend in there, it's just changing the API system. So in this case, we have a collection of lists. Let's create a list, list 1. And there's our first list. And now that we add stuff in here, these are entries within that list. So I'm not going to put some generated stuff like that. Put actual useful information. So we save, and then we refresh, and the information is persisted. So you'll notice that this is, if you take a look at the actual HTML code, you can see that our HTML code is using those Angular directives. So now when we edit something, you'll see the changes appear. So this list value on the left side of the screen is tied to this form. So whenever I update something here, it will update on the other side. This is the scoping mechanism I was talking about. So now that I've saved, if I add a new one, you'll see the animation come in. You can see it animate. And then when you search for list, you can see the old one's fading away. And once again, we can edit data in here. We can save. And then when we delete, it gets deleted from the other side. So I'm not going to go through the code in this example because there's a lot of code, but the GitHub repository is similar to the presentation slides here. And there's a few things I missed because I didn't have enough time for this presentation to put them together, is the promise API, which is delivered by the HTTP. When an HTTP call is made, a promise is returned. This is a useful API to see because you don't want to have any callbacks in your code. Promises dominate callbacks in this case. Form validation, AngularJS has some nice form validation in there. you can use the HTML5 form validation API, and AngularJS will hook into that. We looked at events briefly, but events are important to look at to understand how to communicate between multiple controllers and directives, and more about testing. Here are some helpful resources to learn about AngularJS. There's the docs. There's egghead.io, which is the sort of premier video screencasting website for AngularJS. This is a useful GitHub page. I know the link is kind of long to copy visually, so just click on it. It has a series of AngularJS articles, tools, and tips. And then there's my website, which has help on testing and animations. So that's it. That's my Year of Moo is my Twitter handle, and you can contact me directly at my Year of Moo email. Thank you.
Okay, so I guess we're ready to get going on this. Let me just double check that my slides are all set. Okay, cool. All right, so yeah, this is a session on Backbone.js. I'm glad Angular went first because you can kind of see a slightly more evolved form of web development from Backbone.js. Before I dive in, just a few things. I work at a company called Roboku. We are a software development company in Boston, and we focus primarily on the open web. So it's actually Boku. This is our rebranding strategy here. We do open web technology. So I focus primarily on JavaScript and HTML, CSS, everything that falls under the umbrella of the open web. My alias online is Branyen. So if you want to look for me on there, the slides, everything is available on my GitHub page. I'll switch out to it right now just so we can see that. GitHub.com/TBRANYEN. And if we go here, and let me bump this up a little so you can see my face. If you go to repositories, you'll see Spring 1 Backbone here, and this is the talk today. It has all the slides in Markdown. There's a build step that converts it to HTML. The HTML is already compiled. It's already checked in. So all you have to do is run index.html, and that should load up the slides. And if you want to look at the basic application I put together as well, you can go one up, look at weatherproof.me. Okay. So who am I? I work at Boku. I've been a contributor to Backbone for the past 2 years. I've created 2 popular Backbone spin-off projects, Backbone Boilerplate and Backbone Layout Manager, which help you organize your application, give you like a kickstart, jump right into it. And Layout Manager is more of a view structural thing. If you're from Java, you've probably heard the term Layout Manager before, and it does basically the exact same thing. Okay, I like to start off most of my talks with this, just kind of setting the context. So we have what's called a website and what I'm calling a web app. There's really no 2 differences here. This is just a really bad Venn diagram that illustrates that there are people who have accessibility concerns, people who have performance concerns, and then people who are really good citizens who care about both. And those are the people in the progressive enhancement camp. If you've been following Twitter feeds or any of the web development drama that's been happening over the past week, there's been a lot of talk about progressive enhancement and whether or not it's a good thing, if we should even care about it. I'm in the camp that if you can care about it and it's going to help your user, you should probably focus on that. And what I mean by progressive enhancement is, here's my favorite web application without JavaScript running. And this isn't really a fair thing to show just because TweetDeck, the application that's shown here, is not designed to run without JavaScript. It has a login page that requires JavaScript just to log in through. So if you're getting to this and you don't have JavaScript on, you're doing something intentional. But in contrast, let's look at its counterpart, Twitter.com without JavaScript. If you look at Twitter.com without JavaScript, this is a content site. Its primary goal is delivering you content, and if it fails at that, it's failed at what it's designed to do. So Twitter's been rethinking a lot of its strategic deployment and how it's delivering content to you. So they do all the rendering now on the server. They bring it down to the page. I believe they're using some kind of PJAX. It might just be initial page load that they're really focused on, getting you the fastest, like the content as quickly as possible, making sure that content's available to search engines, and to their users. JavaScript is a really, really interesting and strange ecosystem. It's not really designed for building large applications, but yet here we are designing large applications in this language. Where I'm going with this is that Backbone was designed out of the need to structure your application code in a way that makes sense. Many people have agreed with the MVC, not agreed with the MVC. We have MVVM, MVVRM. I mean, there's some really weird acronyms out there now, but they're all kind of based around the idea that we need smaller pieces that come together into a cohesive application. Backbone is not technically MVC. It's close enough. It has a model. It has a view. Has something like a controller, and we'll get into that in a little bit. So just at a very high level, what is Backbone? For better or for worse, Backbone has two large dependencies that are associated with it, and that's _JS, which is kind of like a functional library, and jQuery or Zepto, which is the DOM AJAX manipulation libraries. You don't need jQuery necessarily to run Backbone. It will run just fine in Node.js environments that do not have a document object model or jQuery at all. So it's not a hard dependency. That's the soft dependency. Some of the large issues with having these big frameworks as dependencies or these big libraries as dependencies are that it's really hard to get a scope of like what is this thing in its entirety. And you can look at more information at backbone.js.org, and the repo is below document-cloud/backbone, which will now redirect you to Jash Keenes, the guy who wrote Backbone's repo. So Backbone is designed around the concept of events. These are mixinable events. You can mix them into any object. You can trigger, you can publish from any code path that you have. So it can be in a totally other part of the application. As long as you have a reference to that object or an indirect reference to that object, you can trigger an event, listen to the changes. This is kind of the philosophy behind Backbone. All the Backbone top-level classes employ events, and they really encourage you to use events to decouple your application. And these slides, I'm going to have to scroll a little bit in some cases. Also, is the font size okay for people? This is fine? OK, cool. What we see at the top here, I'm doing really brief introduction to Backbone because I'm told this is a technical audience that you guys know really the idea of a model, what a view does, what a controller does. But just in a Backbone context, this is what a model is. So the format that Backbone follows for inheritance is that you define first, initialize later. This is what we've been doing with classes and instances for hundreds of years. So we have Backbone model here, and the first object that you pass it are the instance properties. These are like the properties that will be exposed on every single instance that gets created. And the second object is optional, and that's static class properties that you may want to attach to whatever, if it's a model, a router. And I find them kind of useful. I use class properties occasionally, but it's kind of ugly having two objects like that, so typically I'll just use the first one and then directly attach to my definition. And creating an instance just uses JavaScript's new operator. You just call new on it, and now you have an instance. Backbone's inheritance is really, really bad. It's not terrible, but it's just like it's bad for things that you would assume that it gives you. It's a very enclosed inheritance. It's blocked off inside of Backbone and really only exposed through its constructors that it exposes. What I mean by that is, let's take a look at an example. If we wanted to make our own custom router, completely different from the Backbone router, but we want it to follow the same conventions, your code would look something like this. You'd have a JavaScript constructor. You would extend using the same syntax at the top. You can just give it any instance properties. And then you do this sort of weird thing at the bottom where you give it an extend method as a static property, and you give it any of these, backbone.model, backbone.router.extend. So it's like borrowing the extend functionality. It's not directly given to you. This is just kind of a weird caveat. I just figured I would illustrate that Backbone is not perfect, but it was out of the need of being able to structure your code, this was like a godsend to a lot of people. They're like, oh, this makes so much sense. Like, this is really clear. But now that we're trying to extend and go a little bit further, some little things like this linger. Jumping right into routers and history. This is a fundamental part of the web. I'm glad that Mattias brought this up as well in his, that Angular does have a router as well. All client-side applications at the high level should have routing. It's really annoying when you go to an app, and I just used one recently that was saying how much does an app cost, and you can like go through all these buttons, and I hit back thinking, oh crap, I want to change that thing. Well, they don't have history on their application, so it just refreshed the whole app, and that is completely useless, and this is not how the web works, and you're breaking it when you do that. So I would strongly encourage anyone who's designing client-side applications to evaluate whether or not that's going to cause a breaking experience for their users. That doesn't mean every single client-side application needs routing, but it's a very, very important concept to consider. The way Backbone does it is you can just define routes in an object, and then those are a pair of URL to method, and the URLs can have like arguments and splats and all those kinds of things in them. You initialize the router, you call Backbone history start, it starts tracking the history, and it will automatically go to whatever method is currently matched on the route. And if you want to use the new HTML5 history API, I have a little note down at the bottom. You can just enable that pretty easily. The difference between that is you have hash fragments by design and normally in Backbone. It will add like that little append, that little pound sign, and then all the arguments afterwards. It's not very clean. It's really hard for a server to know what you're on if you want to serve content ahead of time. So push state just drops that, and it looks like a normal URL, and you can directly manipulate the address. Views, dirt simple, kind of annoying in Backbone just because how simple they are, but at the same time, it's kind of good because you can be very opinionated about them. So I am very opinionated about them, and I created a plugin that layers on top of Backbone views called Layout Manager. There's plenty of other ones too. Mine's not the only one out there. So defining a view, you attach you associate an element that's in the page with the view, and then it sort of just hooks into that. You can now apply DOM events to it. You can get data in and out of them. And yeah, that's pretty much it. They don't give you a render method, and there's no data binding like we saw in Angular. That's not to say you can't have those things if you want them in your application. There are a plethora of data binding libraries that seamlessly integrate with Backbone views. So it's not the end all. If you want data binding, you don't have to look to another framework. Models and collections, you're probably familiar with these. You create a model that represents your domain data. You have a collection that's many of those things. They're separate in Backbone because of the way that REST resources are usually handled. However, collections can automatically create generic model types based off of whatever URL that you pass it. And what I mean by that is if you have like /myitems, it will automatically create this generic version of a Backbone model based off the data that comes back from the server. You won't have any custom methods or anything. But a typical workflow, and I've created Angular apps. I've created a Ember app, experimental, and I focus mostly on Backbone, and I've seen a sort of trend of how I design large-scale applications. And the trend is like this, and let me boost up this font a little here. I usually start by creating the initial page markup, just get an idea of like what am I looking at here. Create a namespace to attach all my code to. The same thing in Angular. You usually create a global application object that you attach everything to or you associate with. I define all my routers, views, models, all the things, and I'm only doing the definition. I don't do the initialization until everything is loaded. So once all the code has been loaded, now I'm going to call my initialize. And the reason for this is that JavaScript really doesn't have a standard way of loading all JavaScript into the page. There are numerous methods out there like AMD, Browserify. I mean, there's a handful of things out there that you can use to get your JavaScript in the page. But you need to know when everything is loaded because you may have interconnected dependencies. This is where AMD really comes in handy, by the way. The router will determine what to show. So now that our code is executed, it's kicked off the router's like, OK, we're on the home page. Let's do that function. Probably you're going to have some views. They'll hook into the DOM. They'll provide that necessary bridge to your data. And the models will store your data, and you get a lot of glue to keep everything together. And the reason why I say lots of glue is the example app that I'm going to show has a lot of glue in it that I really don't want to take the time to explain. So I'm going to go over the high-level pieces of this application. It's not that much code, so it's really easy to follow. So what we're going to start with is the application namespace. So what I'm going to show in the example, and if there's time, I'm going to go into the advanced branch. There's two branches in that repository I just told you about, the weather app one. There's a basic branch and an advanced branch. The basic branch is like, let's step through everything. Let's really learn how Backbone works. And then the advanced branch is sort of like, how would I structure this if I was being serious? Like, not just for fun here. So the app object, in this case, is just a normal JavaScript object. And I'm associating the main element entry point of where my application is. Because let's say you're using an application framework like Django or Spring or whatever, and you are injecting the application into one small part of your overall site. Maybe it's a control panel. You want an entry point. And really think about that entry point as this is where this application lives, and we're scoping everything to that. And then we have a constant here, which is just the API that I'm using. And it's the Open Weather Map. They have a great API for getting weather information. So that was really cool. And let me start bouncing through what some of this code looks like as I do this. if I go into development, and let me boost up this font size. Font, fizz, maybe I'll go way bigger. Okay, this hopefully looks good. And let's get into the weather. And I'm on the advanced. Check out basic. It's kind of hard coding with my head facing this way, so I'm just going to turn it a little. Okay, so we're in the basic branch. And what I've done here is I've created some HTML. Don't crash on me here. And there's a lot of HTML in here. This is a mobile application, so there's a lot of these meta headers and all that kind of stuff that go up to the top here. I've got some HTML in here. We'll get into the template and all that kind of stuff later. And it looks like I'm probably getting cut off here. So what I'm going to do is go to the bottom and just hit enter a bunch. OK. And we'll get into this stuff in a bit as well. But what I want to illustrate here is that we got the HTML all set up in the page. And let's get into that app object. Delete that. So app.js, just a JavaScript file. It's called app. And we see that code right up at the top here. And we have the start, which I'll get into on the next slide. So starting the application, this is what I was talking about. So once all the code has been loaded, you're going to want to trigger, hey, the application's like, all the sources loaded, let's get this thing going. A really naive approach is just a start method that initializes your router, kicks off the history. So if we see that in the code, oops, let's go back to here. And we'll see that in index.html. Right here, start the application. So I've done this naive script tag approach. I've just injected all this code in the page, doesn't know that everything else is loaded. And then at the very end, once everything has been defined, let's kick it off. And here I talk a little bit about the initial page markup. OK. These are the Backbone dependencies that I've injected into the page. They just need to go before Backbone. If you're using a dependency manager, make sure that they're listed as dependencies of Backbone. And I'm using what's called pure CSS. This is a thing from Yahoo's UE team. It's kind of, if you've heard of Bootstrap or Foundation, it's like that in that it provides default styling for tables, buttons, all of that good stuff. It provides a grid system. And it's pure CSS, and it's very lightweight. So if you don't need all the plugins and bells and whistles of Bootstrap, this is a nice alternative to look at. The router that I've defined here is quite simple as well. It's just 3 routes. So we have the home. We have if you go by a city that you've manually typed in. And lat long is if it uses geolocation to detect. These are the 3 routes. And we see that these are just properties that match to methods. And I've omitted what's inside of them for now. Also, it'd be kind of cool if you actually knew what this thing looked like. So let's open this up. So this is the app. And you can find it at app.toweatherproof.me. Really clever domain name there, I guess. If you go into the search here, if you click, it's going to try and get your location. If it can't get your location, it's just going to abort. If you give it a location, it'll scroll down. It's still unable to get weather at this time, but it's nice that it at least told me that. And then I guess there's some internet connectivity issues for me at the moment. But you can give this a shot on your own, see if it works. Anyway, so we can look at the top here, and we see that the route, weather/Boston, this is actually using push state on the server. Oops. And if you tap on weatherproof, it will go full screen. Just gives you kind of a nicer look on mobile. And if I refresh, it'll actually pick up, oh, hey, we're in, oh, great, got it now. It'll say, OK, we're in Boston. Here's the weather for Boston at the moment. So it's cool that you can refresh. It looks like a normal URL, but it's actually all client-side. And the way that I do that is on the server, I'm using an nginx directive config that says try files. If it doesn't find it, then just always serve the index.html. It's kind of a easy one-liner for getting push state support. OK, let's get back into, let's go into that router, see kind of what's inside the guts here. Backbone is incredibly specific in the way that you write code. It does not offer a lot of shortcuts. It really wants to be obvious as to what's happening. Sometimes that's really great. Other times it's kind of annoying. So typically this is not how I'm going to be writing my application in production. I'm not going to have a lot of repetitive code. I'm going to dry it out, have a lot of methods, other modules that help out. But just at a quick look. So my initialize, I set up some constants in the DOM just so I can refer to elements, not by using the jQuery selector, but by just a property. And since these are classes, you can just apply things right on them, on the instances by using this. So I can do this.background, this.weather, and then in other methods, I can refer to those as well. So I like to set up a lot of stuff in the initialize that will be used throughout the rest of the code. And we see the home link simply empties anything that's inside of the weather model. And, oh, I'm sorry, not the weather model. The weather in this case is the DOM element. So it empties out all the contents that's inside of what weather is currently being shown. And it removes a class off the background that does some animation. So there's not really that much code that needs to happen in a lot of these functions in order to get some rich functionality in your app. And the router is really a great place to start when you're trying to think of where do I put my code. The model here is actually really, really lightweight. I'm just providing a URL. Here I'm showing that it can be a function as well. This is really important because if you just give it a static URL, it's not necessarily going to know how to assemble the data to go to your server. So I'll show you what I mean by that. So in this case, I'm hitting an API, getting weather information. And we see here that the URL is a function that returns a string, which is the API call to make. And I have that constant API that I defined in the app object that I'm referencing here, just to make it a little bit shorter, less redundant. And I have some just logic that says, if we're using the lat long, use this special way to form the query. If we're not using the lat long, just make a basic query using the city name. And then it just returns that formatted URL, makes an AJAX request, gets the data back, and now the model is just going to inherently use whatever response comes back, but maybe you want to do something to that response before it gets into your model. There's a nice little parse method that allows you to convert, in this case, Kelvin to Fahrenheit, and do some of these things. And you can argue that maybe this isn't the best place to put this data, that maybe your model should represent the direct truth that comes back from the server. But since I'm not persisting anything, this is kind of a nice little shortcut. I have about 8 minutes left, so I'm going to talk a little bit fast, go through things. There's just a few more things I need to show you here. The views are important. And then if we get time, I'm going to go over some more advanced concepts. So here's a template that I've created, and it's quite long, and this is where Angular really shines. Angular allows you to just directly modify markup and make some inherent meaning out of how you're structuring things using kind of like a component. You do ng repeat and then make your repeater inside of that. You don't get so lucky inside of Backbone out of the box. And out of the box, people typically use something called _template, which is evaluating raw JavaScript as the template. You see this a lot in PHP and Ruby, where they'll directly run code inside of their templates to generate the content. That's what I'm doing inside of here. So if we look at the top where it says model.getWeather and then 0 and then description, this is me getting the weather forecast out of the model for just the description. It's not as clean as saying this is description. It's a little more verbose. And if we look at that template completely, I'm dropping it in the index.html page. It's not something you want to do in production necessarily, just because you may have a lot of templates and you don't want to list them all in your index.html. You don't really want a build step that concatenates them all in there too. It has code smell. It's not an ideal, but it's very nice for just starting out. If you just want to get a template on there, see how stuff works, use this script hack that was discovered a while ago. I think John Resnick popularized it, but it's just you can give it any type that's not JavaScript, and it won't evaluate anything inside of it. So it's really, really handy. I do this for my slides as well to get speaker notes. I can just write any notes I want. I just do script type speaker notes, and then I can hook into it with JavaScript and display them in the console.log. So this is the template that's going to get rendered into that div above it. So this is invisible to the browser, but your code can pick it up. And then I'm parsing through it. And you see here, I got these weird functional methods going on here, like chaining and picking and eaching, just to get content in the page. This is not ideal, but this is what you get out of the box. You can augment that with any template engine you want, and then hook that right into Backbone. OK. And then my two views here. The weather view, the one that actually displays what the weather is, very minimal, not much, because it's all baked into that little template, and all it's doing is rendering data. The form view, however, does a little bit more, and that's based off of that input that we see here. This is the form view. This here is the weather view. And I'm hooking right into the elements that are already in the page. So it's kind of nice. You don't have to do some weird appending to get this stuff in. It's already there. So I'm just saying this view is hooked into this element. That view is hooked into this div. So the form view has a little bit more logic, because when I click it, it brings me back to the original page. I've got this little geolocation button that will try and figure out where I am. I don't know where this is, Alviso, but it's not Santa Clara. I don't know if that's close by, but it's nice out. And I have this try geolocation flag. I don't want it to keep doing geolocation every time you click in. I'd like to do it the first time. And if it fails, maybe give it a slight delay before trying again, that sort of thing. It's just a nice little Boolean that I've just thrown onto the view, and I can utilize it throughout any of the methods here. Let me see what the next slide is. OK, great. So now I can go into the view code. And we have, I think, 5 minutes. So let's check this out. I'm actually not going to jump directly into the form one. That one's kind of scary. The weather view. I just throw it right here in the global scope, weather view. I can initialize it anywhere else in the code once it's loaded in the page. So we see here that I'm getting the content out of the weather template. That's just an ID that was on that script tag. And then I'm using the template, _template, setting it on the view. I've defined my own render method because by default, Backbone just gives you a no-op. It doesn't want to be opinionated about how your content gets in the page. I'm passing in the view itself as the template data. That's how I was able to do model.getSomething, because I've passed model into the view. It's now a property on the view. The view is passed in the template. It's pretty easy to see. Model on view, view in the template. Now I can access that model. And that's a typical flow of how you get data into your views in Backbone. And I've also created this render failure function that runs when something times out. And it's just like, OK, unable to get weather at this time. And that's what we saw earlier. And now the more complicated view is form.js. And this is where I'm hooking into an existing element. An L property can be a selector, it can be a jQuery object, it can be a whole bunch of stuff. You can look at the Backbone docs and see exactly what that property accepts. I've got some DOM events here. They do a weird, it's not too weird, but it's basically like if you provide just one string with no spaces, that's the event. If you provide a space, you can give it a selector afterwards. So here, if you're doing if you're doing a detect, if you click that detect button for the GPS, it will just run that auto detect method. If you just submit the form, which is what this element is currently, it's the form. If you submit it, it'll do the show weather method. So if we just go to that show weather method. This is really frustrating how. There we go. So what this does is when you show weather, so you've typed in your Boston or whatever city you're from, and you hit enter, it's going to run this method. And the first thing it's going to do is it's going to take that input, which I've cached on the view. It's going to trigger blur. Blur will get rid of the focus. So it means you're no longer focusing on that element. The little clicker is in there, gets rid of the keyboard on mobile. Next thing it does is it navigates to that weather route that we created. And you'll see here that I have access to the router on the app object. I've attached it on that during that start method inside of the app object. This gives me a reference to it no matter where I am in the application. So here I am triggering navigate, weather slash, and then the city name. And then the comma true is important. True will say execute the function that's associated with the route. And you might think to yourself, well, why would you ever not want to run that function? And it turns out in this application, I don't want to run it in some cases. So in that case, that is app.router.navigate. And then the next one, geez, this is really frustrating to find. Well, OK, that's right. What happens is once it finds the weather for, I think it's in the router, this lat long stuff. Come on, bring it up. Here we go, right at the bottom here on line 89. It's like 4 lines up. You'll see app router navigate weather plus this out weather.get model name. What this means is when I provide lat long coordinates to this, the server is going to come back with a relative name. That's what we saw, that Alvisa or whatever, the city name that was up there. That came back from the server. I didn't want to show the lat long coordinates. Now I want to show the real name. So what it does is when it gets that, instead of refreshing the whole content and getting it again, we already have the content. Let's just switch the URL on the user. So now when they link it to someone else, it has like a more meaningful address. So it's like I've swapped it without actually triggering any code. OK. And I have 1 minute left. I just want to really briefly show what that advanced branch looks like. So advanced, oh yeah, that's right, get reset. So this is a little bit more structure. This is using Backbone boilerplate, which you can find at github.com/backbone boilerplate. You can Google it as well. This is structured a little bit more opinionated. So I have an app folder that contains all my images, my modules. These are using AMD by default. This is a separate syntax you can use for AMD that's a little cleaner. It's following what's called CommonJS style requires. So if you see here, we have this thin little wrapper at the top, and now I can just use require backbone, require app. And this is kind of a better way of getting your dependencies and explicitly defining what a module's dependencies are, instead of just assuming they're there in the global scope. So I've run those. This gives you like a build step through Grunt, which was developed at Boku. It's a task runner for JavaScript applications, any kind of web applications. It's got to focus more on the web, though. And it's using a package manager called Bower, and all the dependencies get loaded in here. Instead of just having scripts in a loose folder, I can actually track versions and make sure things don't break. And what else is in here? I mean, that's pretty much it. The other thing is in the index.html, I'm using this special little syntax that's using HTML comments. It's called process HTML. It's a grunt task. What it does is it goes through your HTML, and then when you're ready to build, it gets rid of all your build-specific code, and then it runs and it replaces the content with your production-ready code. What that means is here I'm loading require.js in development. In production, I want to use the minified build, but I don't want a separate index.html file. It'll just replace that one piece. So it looks like I'm slightly over on time. Please feel free to explore this a little bit more. There is a README inside of it. And if you have any questions, I think we're going to be doing a small little panel, so that would probably be the best time to ask those. Thank you. Oh, yeah, sure.
Okay. We don't have a handheld mic here, so we're going to kind of improvise. But let me go ahead and bring Mattias back up, and also invite Brian Cavalier. And we'll have a little round of questions about the various frameworks. First, I want to give, now that you guys have met Mattias and Tim, I want to give Brian a quick just chance to introduce himself and just mention maybe say like 2 minutes about Cujo, which is the framework that we work on as well.
Yeah, my name's Brian. I work for Pivotal, and I work on the Spring.js team on a project called cujoJS, along with Jeremy, John Han, who's sitting down here, and Scott Andrews, who isn't here today. Well, he's here, but not feeling well. So, Cujo is an architectural toolkit. So it's a little bit different from what you would typically consider an MVC framework, in that we focus on tools that allow you to build at the architectural level. So if you're a Spring user and you think of Spring as an architectural toolkit, you use things like application contexts to bind together components of your application that are reusable, maintainable, testable into the architecture that makes sense for your application. We do that same thing in the front end, in the browser, using JavaScript. So we have an IOC container and various other features, modularity, module loader, based on AMD and CommonJS. But basically, we operate at the architectural level and also follow the principles of Spring, where we try to integrate with everything. So for example, if you're already using Dojo or jQuery or Backbone, Cujo works great with those things that you know already and allows you to bring them together in a sane way using rigorous architectural concepts that you're familiar with from Spring. So, all right.
Cool. Thanks, Brian. Well, to kick it off, I'll go ahead and ask the guys a question, but then we'll kind of open it up for you guys as well. So something that I saw both of you mention in your talk was you mentioned modules a little bit. I think you noticed from both of these that you're writing a lot more client-side code than we ever did before with with server-centric apps. So I wonder if each of you could kind of speak a little bit about when you have this much larger client-side code base, how you manage kind of organizing all that code with your particular system, what strategies you use for that. So maybe we'll start with Branyen and go on down the line.
Sure. We're big fans of modules in general, and Cujo has an AMD loader that also supports CommonJS, so we tend to favor those formats, but we're really excited about ES6 modules. If you saw John's talk earlier, they're actually going to be language-level modules in ECMAScript 6. In terms of approaches, though, organizing code, what we've found in building a few large apps is that the sort of traditional model of keeping JavaScript files over here, HTML files over here, and CSS files over here doesn't make as much sense in a lot of applications anymore. And what we've started to do is see that what does make sense is when you want to write a reusable module, you take the JavaScript, the HTML, and the CSS, and you co-locate them in a directory so that it's bundled together as a single component. That's how we think about it, right? If you're writing some view that is a form that is going to be submitted, you've got several things there, right? You've got the HTML that defines the form. You've got the CSS that defines the layout. And you might have some JavaScript associated with that form that does various things. Maybe it triages the data as the user is typing. Maybe it does some triage on submit. Maybe it does some animations. But co-locating those together as a single component gives you a few advantages. It lets you easily see what you're editing, right? Your editor file tree in your IDE, you just pop open that directory and you can see all the files there. Two is you can move that thing around. If you're using a module system, a lot of them support relative module IDs. So you can actually take that directory and refactor your code base by moving it around if you want to without breaking it, because you don't have any absolute paths referencing across directories. And the third thing is you can then functional test that as a unit very easily. You can write tests that behave like like a Selenium test that would test your entire application. If you can write a simple test harness for this one component, you can write Selenium-based tests that test just that component so that you know that it works, and then say other teams or other parts of your team can use that and be confident that it works. So that's one way that we found to do it. I'll turn it over to these guys.
I don't have a ton to add to that, since it's the philosophy that I think most modern web developers are starting to follow, is logically organizing assets at a component level rather than an application whole level, where you don't break things specifically, like you mentioned. It's very annoying when you start getting a very large application. It's hard to see it when you starting small, but I've worked on very, very large backbone code bases through Walmart and my previous employer that were just massive. And it was a pain to have NerdTree that I have in Vim open all the way down, and I have all of this code that's not even relative to each other, just to find the template and then the model and then the module that everything's associated with. It's not a good way to work. So really organizing everything into single folders is the way to go, but it's not always immediately obvious how to build that way. It is relatively obvious in Require.js using its plugins to get text in, or I'm sure curl has a method of loading in other resource types other than JavaScript as well. And with ES6, it has a loader implementation specification that you can override to load other types of data as well. It's not immediately clear yet how to do this in a very solid way. My last application, or 2 applications ago that I worked on, was an Angular project, and I did structure it that way. I had my directives, I had all my controller, I had everything localized into separate folders. And I'll leave it to Mattias to really talk about that, because I don't think my implementation of it was ideal, but it really did increase my throughput for working, because I was like, okay, I need to change this one thing. Okay, all the code is relative to what I'm trying to change. And it was typically I had a right-hand panel and a left-hand panel, and if I wanted to edit one of them, I had the template, I had the code, everything was just right there. So I do encourage people to explore that way of organizing their code. have yours?
Okay, is it still working? Yeah. So to add on to what's been mentioned already, my belief is that what causes a lot of code in an application to fall apart is imprecise planning. Like it's inevitably going to happen. However, if you can use a framework, if you can use a tool that will save a lot of the code that you're putting together, then definitely do it. Because it's going to be more work to have to maintain your own code than it would be to take a framework, choose a framework, and pick something that would fit your needs. Now with Angular, there is a proper modular system built in place, and on the tutorials that they say online, they'll tell you to separate your directives, separate your controllers, separate your filters and animations, but I actually don't think that's the best solution. Instead, take a look at your application, figure out what components can be isolated from each other. If you say that you have a calendar page, and say that you have a listing page, if you can isolate the features from each of those pages into separate modules, and then provide testing code for those modules by themselves, that's a good way to go. Now, JavaScript code can easily be abstracted into another module, and what you can do with Angular is you can have multiple ng app directives, which will separate parts of a page into another module. When it comes to storing templates in HTML files, yes, have a separate directory for each module, and same thing goes for CSS. And try to have each module isolated from the frameworks they use. It's a little bit challenging, but the more that the things are not dependent on each other, the better off you are.
Do you mind if I say something?
Sure. Yeah, go ahead.
It's a good question, Jeremy. Mattias, that last point that you made, I think, is really awesome. That in general, I think as we build bigger and bigger apps, one extra piece of organizational information that people need to consider is keeping your application code separate from your framework code. And there's just tons of benefits here. One, which Tim mentioned, was we're starting to see package managers for the front end. You know, on the back end, Node is sort of the 800-pound gorilla, and NPM, you know, is sort of the associated 800-pound gorilla of package managers. But on the front end, it's not really a solved problem yet, but it's going to be. And so the ability to upgrade packages, install packages, manage versions is going to become much easier, much more prevalent. So keeping your application code separate is going to allow you the freedom to do that more easily. Cool, here you go, Tim.
Yeah, just to bring up one of the challenges that Bower's facing right now is built assets. So like the pure CSS framework that I was showing you, it's in Bower, but it's only the raw source, so you can't just drop it into your page, and that's because Bower doesn't allow you to publish built assets, and they don't want to check in published assets. So yeah, it's definitely not a solved problem just yet. So what I was going to add is when it comes to modules and when you're building, we often talk about JavaScript and we kind of miss CSS, which is usually one-to-one with some of our code where we have like a specific component, we have a style sheet that's associated with it. And I've been exploring different ways of how do I actually modularize those two. We don't have a script loader for CSS, but we do have something that's at import inside of CSS, which allows you to remotely load CSS files. So one approach that I've been taking is making one style sheet that gets loaded in my page, filled with @imports that reference the CSS that I need to load, and then during a build step, I use an AST parser that goes through, finds all those style sheets, parses them from whatever source language they may be in, which could be stylus, less, any of these preprocessors, and then concatenate them into a single build that's distributed for performance reasons. So I'm curious as to what other people have been thinking about CSS, not just JavaScript, when it comes to a web application and how you structure those things.
So another thing I might add about CSS is anybody familiar with Smax? It's not like a framework per se, but it's more of a naming convention for CSS. Now I found that to be an amazing solution. However, that can get out of hand very quickly. And you have to be very disciplined to follow that naming structure properly. So it's just like working on a big software project. If you're working with a team of people, in the beginning, start with your naming convention, start with the structuring of your CSS code, because that also falls out of hand. How many times have you reused CSS code from one website to another? Probably never, right?
Well, there's Bootstrap. Now everybody reuses it. So,
yeah.
Anybody have a question for these guys? Let's see. We'll start here in the front.
Mm-hmm.
How about in the JavaScript, we have like a similar tools, and how can we integrate with the Java or better one button to everything?
Right. So just to repeat the question for the video, we're talking about how in the Java world we have all these pretty mature tools, Maven, Jenkins for CI. Certainly, and this goes back somewhat to the last question, as you get these more complex front-end applications, how do you integrate this tool chain with your server-side technology, whichever one you're using? And of course, these guys are all using Java. So any thoughts you have there for making that happen?
Yeah, this I mentioned package managers and how they're sort of evolving in the front end, and we're not quite there yet. We're sort of in the same position for build systems, and you've heard AMD modules mentioned, and require.js and curl. They do have associated build tools that can take all the modules that are scattered about your project and concatenate them into a single file. That's just really one small piece of the puzzle, right? Once you have that, you have a JavaScript specific tool that can do that for you. You'd like to integrate that into something like Maven or Make or whatever you use, Gradle. Grunt is, I'll let Tim speak to that a little bit more, is a tool that's targeted more at web applications that can do a lot of that stuff. It's very much like Make or Gradle. But there's other things to consider too. There's CSS, there's HTML templates, and how do you take these nicely packaged components that we've been talking about up here that have associated HTML and CSS, and how do you build all of that, including the JavaScript, into maybe one file if you have a small application, maybe several files, because you don't want to necessarily deliver the entire application on page load to the user, because that's going to delay, cause a bad user experience by delaying the initial page render. If you're doing client-side rendering, you got to load all that stuff before you can render the templates. So maybe you break it down into 3 or 4 large files, one which gets loaded initially, another which gets loaded on demand when the user visits that screen that people don't use very often in your application. So we want to be able to incrementally deliver these applications. And that's a really challenging problem, is taking an application and segmenting it into large units in an automated way that can be loaded on demand. So that's one particular challenge that hasn't really been solved yet, but there's a lot of work going on in the community around that kind of thing. I don't know right now if there's really a good answer to how do you integrate with Maven. You can always do something like exec, right, and run an RJS or a cujoJS cram build from something like Maven or Ant or Gradle. And right now, a lot of people are doing that. But we haven't seen yet this really tight integration between the back end and the front end build process to deliver an entire application, but we're getting there. Sorry, what was that? Oh, okay. Someone mentioned Maven overlay for doing that kind of thing. Okay. Great. Thank you.
So when I was at Matchbox, my startup little thingy that I had, my fling, I guess is what you could call it, I was experimenting with large web applications, and we did have a continuous integration deployment. It wasn't Maven, but we did, I think, have Jenkins integrated in there, and we used Grunt. And it was very, very simple for us to get this working. It was actually really, I don't think I need this. It was I do need it, sorry. I thought my voice was louder than it is. Okay, yeah. So we did have an integration point for that, and it's because Grunt just has simple exit codes, so it was just able to pick those up and then take the output of what came out when something failed, and then that was delivered into our pull requests when we submitted them. All the unit testing, all that kind of stuff is in JavaScript land because we ran code coverage on it. So we do use Karma, which came out of the Angular project, and this is actually kind of great how everything's kind of harmonizing. We're all kind of standardizing on little things here and there that people have come up with. So like AMD is well shared. Karma is becoming kind of a standard for testing now. And we had that integrated. It would spawn a headless Phantom.js, which is just a Chrome or WebKit headless process, run all our tests inside of that, and then come back up. So we didn't have to like spawn out to any of well, we weren't Java, we were Python, so whatever the Python system we were using. Didn't have to run any of our code. All it did was execute processes and then look at the exit codes that came back in the output. So that's how we handled that. And it was a fairly simple integration. I mean, I didn't have to implement it, but I was told that it was really trivial. So you got yours.
So can you hear me? Is this working? Yeah? So the tricky thing with testing backend and frontend is that, like Tim said, they're two separate worlds. You have the client-side code and you have the backend code. And yes, testing front-end code is easier now with tools like Karma. And Grunt can sort of put together the dependencies to make it run. But if you put it into Jenkins, you're going to have some server it's going to have to communicate over. And if you can get away with putting a private server somewhere that has an IP address that it communicates with that has a testing database, then that's a good way to go. Regarding Maven, I can't answer that question. I'm not really into Java backend development. But regarding Karma, Karma does return exit codes. And Grunt can tap into those exit codes. And then you can hook that together with Jenkins. So on the AngularJS project, yes, question? OK. So on the AngularJS project, what we do is we have a CI server for every pull request and build that gets pushed in. So if I'm editing something and I push it to the server, it will send me an email if it's failed. So it's typically IE8 and IE9 bugs that happen. But so that one works together with Jenkins. And if you can set up your Java build process with Jenkins, then that might be the way to go. Any question?
In regards to Maven, Jim4 has a project called WebJars to solve the transitive dependencies based on Maven between different JavaScript libraries. Do you have any experience with that?
Well, I can answer that. Yeah, there was a mention of WebJars as a project that James Ward, who actually spoke yesterday, he maintains that is somewhat trying to at least solve the dependency problem with these client-side frameworks but in a Java-centric way. Basically, he takes various popular JavaScript libraries, things like Bootstrap as well, and actually packages them in jar files, publishes them in a Maven-compatible way, so that you can actually just add these dependencies to your Maven or Gradle build and actually pull them down. If you actually use some of the stuff like actually some of the things I'll be talking about tomorrow, the Spring resource support, it's pretty easy to actually just serve things out of the jar file, set that up with your Spring MVC app or whatever. Let's go ahead and probably take, Brian had one more thing to add.
Just wanted to describe real quick the setup that we use in cujoJS for testing, and it's very similar to what these guys have described. But we use Travis as our CI server. It's a free CI service, and so it automatically integrates with GitHub. So anytime we push or get pull requests, Travis can run our unit tests, and we try our best to structure our JavaScript code so that the dependency on browser-specific libraries and features is very isolated. And what that allows us to do is write a lot of unit tests that are agnostic of the browser and can be run in Node. We use a testing framework called Buster.js. There's a lot of good unit testing frameworks for JavaScript. So you can pick one, but we use Buster. So what happens when we push to GitHub is Travis pulls down the code, runs all of the unit tests that can be run in Node on Travis, and then we have sort of an unofficially, well, not really released project that we're working on that integrates Travis with Sauce Labs. And if you're not familiar with it, Sauce Labs is a browser testing service. They'll fire up browsers for you on virtual machines and load a page and whatnot. And they have an API. So from Travis, we can actually initiate Sauce Labs tests, and those can return exit codes to Travis. So if something fails in our code on IE6, it can fail the Travis build too. So similar to what these guys are talking about, I think things are, that kind of setup is gaining momentum, and we're going to see more of it.
Probably have time for one more question is my guess. I think there was somebody in the back here who had a question, or, yep. For just the JavaScript side, so yeah, what tools do you use for CI, for that kind of pipeline? Brian probably already made that clear for the Cujo side.
Like I said, at the previous employment, we used kind of a Python build system, all that kind of stuff. If I had my ideal, it would probably be with Travis CI, kind of like it. People were moving towards Sauce Labs. AngularJS just announced that they're using Sauce Labs now too to do all their testing. It seems to be a good way to go. So yeah, Travis CI, Grunt, Sauce Labs, I think that covers pretty much what I would call ideal.
So AngularJS also uses Sauce Labs, I forgot to mention that. And that speeds up our testing setup. So my ideal setup would be to use Karma with Chrome, Opera, Firefox running. And then to use some form of a WebDriver to test out pages. And the thing you can do is you can take your API and you can mock the API directly to the website. That might be a little bit more work, but that way you don't have to have a server running in the background constantly feeding data to the testing code. So I haven't actually done that yet. That's just an idea that I had. So the two testing tools I use in my testing build would be Karma and then a WebDriver, which will be Protractor for Angular, but for right now it will be Angular Scenario. Regarding other JavaScript languages and frameworks, if you can find a WebDriver that fits your needs, use that, but always stick to doing unit testing too. If you, the more unit tests you have, the better, because like anything isolated and programming, web development, is always better than anything complicated and compounded together.
All right. So with that, I think I'll we'll call it and let you guys go get lunch. Thanks everybody for coming.